So in our next example, we just have a nice little beam, right? Again, we have our roller and we have a pin connection. And this is point B, there's a point C, and there's an A. And there will be a distributed load along the length of it going from the end to A, right? So you have so many, and this is in 3 kip per foot. And the measurements here are 6 feet. This is 4.5 feet. And this is 4.5 feet again, right? So what are the internal forces at C? How do we do this problem, right? So we have to figure out which section to work with from the left or the right. So let's say we're going to choose the right sections, right? And why is that? Because it's a bit simpler and there are no external loads on the B section. You have external loads over there, but none over there. So let's draw the free body diagram for the whole thing, right? So what you would start out with is the reaction forces at B. Let's say you have a BY and a BX. And remember, the arrows are just relative. I could have really drawn this arrow going downwards instead. I want it to be more accurate. Then you have a normal force acting at A, right? So you have an AY component. And then because this is 3 kips over per foot, you'd say 3 times 6 is 18, and that would be acting in the center, so this would be acting 3 feet away. We can treat that load as just being 18 kilopounds, right? We apply the equations of equilibrium. We sum the forces in the X. Why do we do that? Because it's nice to be able to say that Bx is equal to 0, right? So similarly, the next thing that we could do is sum the moments about some point. Let's say we do it at A. We'd only have to solve for By. So sum of the moments about A would give us negative By. Remember, I drew this going up, but if we know that there's a normal force right here, we can pretty much say that that would be going in the other direction. So let's say By, or if you flip it around, let's find out, right? Negative By times 9 plus 18 times this total distance. Remember, this is 4 plus 4.5 plus 4, give us 9, and this total distance is 9 plus 3, that's, oh no, some of the moments about A, so we're just doing 8 times the distance here, which is 3, and remember this is 9 right here now. 18 times 3 would give us 0, so By would then be equal to 6. Alright. So actually By would be, to be accurate about this whole thing, By would be equal to, this is what our diagram would look like. You have a force there, a normal there, and a Y component, right? So after we sum that, we could say, what's the free body diagram of just this section? Because the main thing that we're trying to figure out is what the cuts are right there. So given that this is B, and we have the cut right along there, we have some normal force, right? And we have some reaction moment, and we also have the shear force acting downward, VC at point C, right? Summing the forces about the X, we can say that normal force at C would be equal to 0, which is equal to summing the forces Fx, right? And then similarly we can say as well that if we sum the forces in the y direction, you'd have negative Vc minus 6 is equal to 0. So Vc is equal to negative 6 kip, right? I don't know where that came from. It's a remnant of something else. You would also then have some of the moments about C, right? And you'd have negative 6 times 4.5 minus MC is equal to 0. MC would be equal to negative 27 kip feet, right? So some of the moments about C, right? We still have the By component, which was acting downwards, right? 6. So 6 times this distance, which we worked out to be 4.5, would be equal to the moment, which is reactive. We treat it like a wall, and then we'd get the moment to calculate. 6 times this would be MC. MC is equal to that, right? 27, negative 27 kilopounds per foot.